We're now going to look at determining where a function is increasing, where it is decreasing, or where it is constant. Essentially, a function is increasing over some x interval, and we'll call that interval from x sub 1 to x sub 2, if that function evaluated at x sub 2, or the y value associated with x sub 2, is greater than the y value associated with x sub 1, then we say that the function is increasing over this interval. Similarly, if we have a function where the y value that's associated with x sub 2 is less than the y value that's associated with x sub 1, we would say that this function is decreasing over that interval from x sub 1 to x sub 2. However, if we travel from x sub 1 to x sub 2 and the y values do not change during that interval, these y values are constant, and so we say that that function is constant over that interval. Now, something that we need to notice is that we're going to use an x interval to describe where a function is increasing, decreasing, or constant. So let's look at this quick example. In this graph, we have a function, and we're going to, first of all, determine where that function is increasing. Now remember, we're going to describe where it's increasing using an x interval. And we want to think about the function increasing from the left to the right. All of the increasing, decreasing, and constant questions are answered by traveling from left to right through the domain. So let's zoom in here just a little bit to see that as we move through the domain from left to right, the y values in this interval are constant. They do not change from this point to this point. And then as we continue to move through the domain from left to right, the y values will be decreasing here. They decrease to this point, and then they're constant for a moment to this point, and then those y values start to increase again. So how do we answer that question then? Where is this function increasing, decreasing, or constant? Again, we're going to use an x interval to describe where those changes are happening. So from x is equal to -3 to x is equal to -1, this is one of the x intervals over which the function values are constant. So we'll say from -3 to -1, the function values, which are the same thing as the y values, are constant in that interval. And then starting at that x value -1 to the x value +1, from here to here, the y values or the function values are decreasing in this interval. So we'd say from -1 to +1, the function values are decreasing. Again, we're using an x interval to describe where that happens. So in this interval, the function values are decreasing. And then the function changes again from x is equal to 1 to x is equal to 2. From this x value to this x value, the function values are constant. So in order to tack on another constant interval, we'll need to use the union symbol and say that from the x value 1 to the x value 2, that's another region where the function values are constant, not changing. And then after that, our function values again begin to increase. So from the x value 2 to the x value 3, again we use x intervals to describe where the function is increasing. From x is equal to 2 to x is equal to 3, the function values are increasing. Now in these last two questions, the first one asks for the value of f at -2, which essentially means that we're looking for a y value or the y value of the ordered pair that's associated with the x coordinate -2. So we go up onto the graph and we look for the x value -2. Well, that's happening right here, and the corresponding y value, since this is a constant region, this ordered pair would be -2 as the x coordinate and +2 as the y coordinate, so the function evaluated at -2 is going to just be +2. So that would be the answer to part D. And then determine where the function is equal to -1. And anytime we're asked the question where something is happening, notice we were using the question where in parts A, B, and C. Anytime we're asking where something is happening, the answer to where it happens is going to be either an x interval or an x value. And that just depends on the scenario. In this particular question, where is the function equal to -1? That's actually an interval because there are several different x values that have a y value that is equal to -1. Because y is equal to -1 for all of these x values. And so that would be the answer to this final question. Notice we are going to use a closed interval here, meaning that we are using brackets including the endpoints because when x is equal to 1, the y value is -1, so that would be included. When x is equal to 2, the y value is -1, so we would also include that in this solution.